Right, once again, an unknown distribution. We don't know what the distribution is, but that doesn't matter because the probability we're looking for is about the sample mean. If it's about the sample mean, we're allowed to assume that normal distribution as long as our sample size is large enough, which it is in this case. So an unknown distribution has a mean of 45. So our original mean is 45. Our original standard deviation is 8, and we are taking sample sizes of 30 drawn from the population. So groupings of 30, and then taking that average and counting that as like one piece of data. Another group of 30, take the average, count that as one piece of data, all right? And these data that we're collecting, these sample means, are creating this normal distribution curve that has a mean at 45, right? The mean of the means doesn't change, which makes sense. The center is still at the center, but the spread, the standard deviation, instead of being 8, is going to be much smaller, but we need to figure out what that new value is. The new standard deviation, the standard deviation for X bar, instead of the standard deviation for X, is equal to the old standard deviation divided by the square root of n. The old standard deviation divided by the square root of n. All right, let me pull out my calculator and type this in to get a decimal approximation here. I recommend when you're using the online calculators, I mean, you can leave your answer like this. I type this in and we've got 1.4606, and that's rounding. Right, what I was going to say is I recommend when you go to put it in on your online calculator, you put as many decimals as possible because we want to make sure that we're letting that normal curve be as accurate as possible. But generally, 4 decimal places is safe enough when you're writing out that value. So X bar, our sample mean, can be normally distributed with a mean of 45 and a standard deviation of 1.4604. 4606. Or more accurately, 8 divided by the square root of 30. That was exactly where that value came from. So visually, we have our normal curve. 45 is in the middle, and this would be 46.4, and add another 1.4606, and add another 1.4606, right? This kind of shape, but you see how small those are. And we are looking for the probability that the sample mean, that's our X bar, is between 42 and 50. The probability that X bar, the sample mean, is between 42 and 50. Remember that if you're between, your inequalities are getting bigger as you go. 42 is the smallest number. My sample mean, my average of those 30 people drawn in, is going to be something bigger than 42. The alligator mouth opens towards that X bar, and that's going to be something smaller than 50. These inequalities face the same direction. They're both less thans or less than or equal tos. All right, now I go to my online calculator. I put in this mean, this standard deviation, and I make sure I have the in-between toggle selected. We're going between 42, which is, somewhere maybe over here. I know I drew these lines, but then I didn't do the math. It's okay. 42 to 50. 50 is probably pretty high up there. If this is 1.4, think about it as 1.5, that's to 48. That's 49.5. It would be something on the other side over here. And that's a rough estimation that I just did there. I was doing 1.5 additions instead of 1.4606, which is what our standard deviation is. All right, but just to give us a rough picture of what we're looking for. Now, when I go to my online calculator, I know exactly what it should kind of look like. All right, we have a mean of 45. We have a standard deviation of 1.4606. All right, your online calculator here won't accept D8 divided by the square root of 30, okay? It won't take that as an input. So you do have to write in the decimal approximation. And we are going between 42 and 50. 0.9797. Again, make sure we are practicing the proper notation. Write out the distribution itself for X bar. In your probability question, put X bar there because our question was for the probability of the sample mean being between two values.